Hi everyone, nice to meet you. Welcome our Zmotion technical support. Today, a new series knowledge is coming. That is PLC programming. And today, the first part shows PLC programming rules. Before, Zmotion shared how to develop a PLC in RTSys. RTSys is a programming software provided by Zmotion. It's free for you, and actually it's updated from our old friend ZDevelop. PLC debugging and related development information are described in that article. You can review it in our Zmotion website support menu. And this time, more details about PLC programming will be described. There are all four main contents. They are linear interpolation, circular interpolation, electronic cam, and electronic gear. Therefore, today is our first function introduction, linear interpolation in PLC programming. And this knowledge will be shown clearly through three aspects: PLC rule introduction, interpolation function introduction, PLC linear interpolation application. That is, three corresponding videos will be shared with you. Okay, today let's see some PLC programming rules. Firstly, let's learn the first PLC programming language, LAD, Ladder Logic Programming Language. LAD is used the most in PLC. It uses relay control circuit, and it simplifies symbols for general relays and contactor logic control. Figurative, intuitive, easy to use. Therefore, some engineers prefer PLC programming. Next, back to PLC programming. PLC running logic and hybrid programming of PLC and BASIC will be talked. For PLC programming, it executes from the left bus bar, that is, from the left to the right, from upper to bottom. And one scan period is from first line to end. Keep scanning in this way until stop finally. While PLC is running, it executes self-detection, communication processing, input detection, program execution, and output refresh. Before that, it scans whether there is an error. If yes, parts off and errors are shown. Then does other communications. Please refer to this process, and this is a whole scan cycle. Read first, execute the program, refresh elements, output, drive external devices. Complete once, scan again. Therefore, it can be seen one scan cycle includes three steps: input detection, program execution, output refresh. Input detection includes reading and writing. Read each terminal's states and write them into corresponding input state registers. In this process, please note the input signal wise must be bigger than one scan cycle. Then it will enter program execution. This includes scanning and saving. Scan each PLC command in cycle, then save their operation and processing results into output state register. Attention, the changed signal is read only when next scanning. All completed. Output and drive. It's mentioned the scan period. Actually, it depends on program length, CPU speed, and command type. Then, different kinds of time can be checked by different special registers. Scan time through the 8010, minimal time through 8011, maximal time through 8012. For now, PLC running logical is over. Enter our hybrid programming usage, specifically PLC and BASIC mix. As we all know, BASIC is also our old friend, a kind of programming language. In the mixed usage, the first one is PLC calls basic commands through EXE or EXEP instruction. The difference is that EXE executes all the time, EXEP executes once, and is a post form of EXE. So how to add it? Please see this. It can be concluded the form is EXE and add one command. So this kind of writing method, EXE add basic command. So this one is PLC calls move command. Move in BASIC means linear interpolation function. When x0 is in rising age, that is, when x0 becomes on from off, trigger to execute the move runs. For EXEP command in here, the same effect, but if it is EXE, when x0 is conducted, move will execute in cycle. It may cause blocking. Therefore, please note the pose contactor points. For this, x0 pose triggers. For this, EXEP pose triggers. In addition, PLC can call subprograms through call command, but they must be in the same project, that is, the same one, .cpj file. First, let's see PLC calls PLC subprogram. Use call. Add the name of PLC subprogram. Then use LBL to define subprogram. Write subprogram main commands. Next, SRET is needed for return. Second, PLC calls basic subprogram. There is one difference. Add should be added before the subfunction name. The name is the basic command name. This means whether to pass the parameters. If yes, use the local register. Here, LV0 is used. That is, save parameters into LV0 at first. Then it calls basic. Date is saved into S1. Please note it must be global type because it belongs to crossfire calling. Third, basic calls PLC file. Actually, it can open PLC file directly in BASIC. Use the run instruction to call PLC task. Let's see one example. Open PLC file as task 6 through run. Then the run task means define the sub as task 2 to run independently. Then in PLC, call sub A, a subprogram, a separate task. SRET can bring with return value or not. If yes, only can be saved in LV local register and read it through return. The type is floating point. Therefore, this is open PLC task to call it. Next, call PLC subprogram directly, not as task to run. In BASIC, use call to call one PLC subprogram. Then return the place where BASIC calls. If run task is used, it will not return. The example, write call, and add function name. Then it will execute here. The subfunction is defined by LBL. Same, use SRET to return. Return here. Parameters are saved into LV1. Here, through return, read LV1 date and assign it for B. So this is basic calls PLC subprogram directly. Okay, now basic PLC programming rules are described, and the next video will show interpolation function. Thank you for your watching. Have a nice day. See you next time.